You may have noticed in my math lab that section 10.4 is split into two different pieces. 10.4 covers installment buying, and there are two different types of installment buying. There's fixed installment and open-ended installment loans. We're going to focus today on fixed installment loans, but we'll go ahead and define them both. A fixed installment loan has a fixed payment over a specific term, so you pay it out over a set number of months. You know that your payment every month is going to be $200 and you're going to pay that for 36 months, for 3 years. Types of fixed installment loans include tuition, whether you have done an installment plan with the college or whether you're taking out a loan for tuition. Car loans are fixed installment loans. If you buy furniture on credit, that's going to be a fixed installment loan. Things like that. They have set payment, set term. Open-ended installment loans are when you're allowed to make variable payments. So there isn't a date by which you have to have it paid off. And our major example of an open-ended installment loan is a credit card. So if I can make variable payments every month, that's going to be a credit card. Now, a credit card will require a very minimum payment, and if you are late, they will add fees that must be paid by the next month, or you'll end up with more interest on those fees. But in general, you can seriously take your time paying back a credit card. Now, credit card is not the devil. It is not always bad. Credit cards can help you establish credit if they are used wisely. Credit cards are also the way most people destroy their credit, the quickest and easiest way to mess up your credit, because they have variable payments, because they only require a very minimum payment. You end up charging up your credit card, and then those interest fees pile up and it just gets on top of you and you don't get it paid off. So credit card debt can be a real problem, but we're not going to focus on credit card debt today. Today we're talking about fixed installment loans, like for tuition or furniture, cars, things like that. We've already introduced APR, which stands for annual percentage rate. Our annual percentage rate is what is also called the true rate of interest. I don't know that we've talked about finance charges. A finance charge is just the interest that you pay plus any additional fees. Now, this would include late fees if you didn't make your payment on time. It would also include things like loan origination fees. I know my husband just purchased a car, not a new car, it's a used car, and we paid about half of it down and then financed the rest. And he was very frustrated after getting the loan papers back because there was a $500 loan origination fee that we could have avoided if we had just gone ahead and paid it up front and then paid ourselves back into our savings. So just be aware of those finance charges. The total installment price is the sum of all monthly payments plus anything you pay down. So for example, my husband's car, that down payment that he made, when we think about the total cost of the car, when it's all said and done, when we finally have the title in our name, the total cost will include that down payment that he made, the origination fee, and then all of those principal and interest payments. Now, when we calculate a monthly payment, that monthly payment is going to include the principal that we borrowed and interest that we are paying on the loan. So anytime we look at a monthly payment, we're talking about principal and interest. Now, our monthly payment formula is found on the formula sheet, but we're going to go ahead and put it here and talk about it. Payment, PMT, is what we're calculating. So how much are we going to pay each month on a loan? And the variables involved in the formula should be familiar to you. P is for principal, the amount that we borrow. R is for the rate of interest as a decimal. N we have talked about as the number of times compounded for compound interest. For our payment formula, N represents the number of payments in a year, number of payments per year. And because we are focusing exclusively on monthly payments, that means we're taking 12 payments a year. So for our calculations in this course, N is going to be 12 for our payment formula. Then our denominator is a little bit more complex. So pay attention to your denominator. You have 1 minus the quantity, 1 plus R over N, that same ratio from the numerator, raised to the negative NT power. Now, N again is 12 here. T is the term of the loan, the time in years that you are paying it back. One thing that I want you to notice, I need you to grab your calculator, because this negative exponent, that negative button, is down here at the bottom. It is not the same as your subtraction button. The negative button is down here. We have used this button for the second function to get our last answer pulled up. Now we're going to be using it for this negative sign in the exponent. Okay, let's do an example of calculating a monthly payment. For this problem, we are borrowing $20,000. That's our principal. For 6 years, that's our term or our time that we have to pay back the loan at 7% interest. That's our rate. So we've got principal, rate, and time. Remember, N is 12 because we're making monthly payments. So we're making 12 payments a year. All right. So when we calculate our payment, we're plugging it into this payment formula. We take our principal in the numerator times the ratio, the decimal percentage, the decimal rate over 12, because 12 payments a year, all over, and then our denominator is 1 minus the quantity, 1 plus that ratio, raised to the negative NT, and here T is 6, exponent. So let's talk about a couple of things that we need to remember. The first thing is that we don't want to round early. So don't round early. When I work out my numerator, I'm going to get usually, almost always, an ugly decimal, something that goes on and on forever. When I write it down here, I don't want to round it off to the nearest penny already, because when I make that rounding here, it's going to very likely mess up my final answer. So what I'm going to do is I'm going to keep several decimal places in my numerator so that I haven't rounded too early and it affected my answer. The second thing that I want to talk about is this exponent in the denominator. Remember that it's going to be negative. And also remember that it's a good idea, it simplifies things if I think about what it is going to be before I get there. For example, here I've got 6 years, monthly payments, 6 times 12 makes that 72. My exponent is a negative 72. Okay, let's go back into our problem, grab your calculator, and we're going to work through this example. Let me make sure you can see my entire calculator. There we go. So in the numerator, we have this, this principal multiplied by this ratio. My ratio is in parentheses. We're going to go ahead and kind of strictly follow order of operations and do parentheses and exponents first. So we're going to start with our ratio inside parentheses, do 0.07 divided by 12, enter. And then I'm going to multiply this by the 20,000. Remember, I don't have to type this back in. I can just say times 20,000, enter. That's my numerator, 116.6, repeating until I run out of space. So $116 and then point lots of sixes, because that's what my numerator looks like. I do not round it early. Now let's go back and tackle order of operations in our denominator. Parentheses and exponents first. So I'm going to start inside the parentheses with this ratio, because multiplication and division come before addition and subtraction. So once again, I do 0.07 divided by 12, enter. This time I need to add 1 to that, because that's what's inside those parentheses. So I push +1, enter. And that's the quantity represented inside that I need to raise to the exponent. That's my next step, exponent. So the exponent button is that little house top. Exponent, and our exponent set is negative. Don't miss the negative button. Negative 72, enter. Now, this decimal is what I need to subtract from 1. 1 minus this. Order of operations with subtraction, that order matters. It's going to give me a different answer if I do my decimal minus 1. Don't do that. I need to start with the 1 minus. So I type into my calculator 1 and then I use subtraction and I pull up that answer. So I'm going to do second function down here to get that answer back up. Enter. And that is my denominator, that 0.34, etc. Now, I'm not going to worry about writing that down because I'm just going to pull it back after I type in my numerator. So I need to do numerator divided by denominator. Let's type in our numerator, 116 with lots of 6's in the decimal, divided by, and then pull up that remembered last answer. So second answer, and there's my payment. I need to round it to the nearest penny. So we've got $340.98. So my payment is going to be $340.98. Okay, now we'll do a couple more examples of those together with the calculator. The next question, how much do you pay over the course of the loan? Well, to figure out how much I'm paying principal and interest over the course of the loan, I need to take the number of payments times the amount of the payment. Well, I'm writing a check for $340.98, or I'm having a direct debit from my account of $340.98 every month for how many months? Well, I'm going to be doing it for 6 years. There's 12 months in a year, so my exponent here, 72. I am making 72 payments of $340.98. How much money is that total? Well, I need to come to my calculator and I'm going to type in $340.98. If I leave this, it's going to give me more than I need and it's going to skew my answer and I'm not going to be exactly correct. So I need to make the exact payment that I'm going to be paying, $340.98 times 72 payments. So this is the amount total that I am paying principal and interest. My principal and interest payments add up to $24,550.56. The next question is, how much interest do you pay? Well, what was our principal? How much did we borrow? We borrowed $20,000. We paid back $24,550. So how much of that was interest? Well, take your total that you paid in your payments and subtract the total that you borrowed. And we see that over those 6 years, we paid $4,550.56 in interest. Okay, let's look at the next example. For our next example, we're borrowing the same amount of money for 1 less year, and our interest rate has stayed the same. So the only thing that has changed is that we're borrowing the $20,000 for 5 years now. We're paying it back over 5 years instead of 6. So when I set up my payment formula, I have my principal times that ratio 0.07 divided by 12, still 7% interest, over 1 minus the quantity, 1 plus that ratio, raised to the negative 12 times, and now t is 5. So instead of my exponent being a negative 72, now it's a negative 60. Look back at the last problem if you don't remember. Has anything changed in my numerator? No, it has not. That means that my numerator is still 116 with those repeated 6's for the decimal. What has changed is my denominator. So let's go in and let's calculate that denominator again. This is good practice. We start inside our parentheses with the ratio, 0.07 divided by 12. Then I add 1 to that. And then that is the amount that I need to raise to the exponent. I'm trying to get the light so it's not quite so glary on you guys. That is the amount that I need to raise to the exponent. So I push the exponent button. And remember, my exponent this time is a negative 60. Enter. All right, that is what I need to subtract from 1. 1 minus this. So that's what I type in. 1, and use your subtraction button this time. Second answer, bring that back up. That's my denominator, 0.29459, etc. So I'm going to type in my numerator, 116 point lots of sixes, divided by, and then I'm going to have it bring back that answer, second answer for my denominator. And my payment that I get this time is $3.96 and rounds to 2 cents. So if I pay it off a year faster, my payment went up a little bit. The payment over 6 years was $340.98. So I've added, $55 to that, $56 to that. How much do you pay over the course of the loan this time? Well, how many payments am I making? I'm making 60 payments because I'm making monthly payments for 5 years. So 60 payments times the amount of the payment tells me how much I'm paying principal and interest. When I multiply this together, I get $23,761.20. How much of this is interest? Well, how much did I borrow? I borrowed $20,000. I paid back $23,761.20. So when I do that subtraction, when I find the difference between those two amounts, I see that $3,761.20 of that was interest. So if you compare it to the last, when I paid over 6 years, the payment went up when it was just 5 years, but the interest amount went down. All right, I want you guys to do 4 years interest. So we are working with the same amount for the loan. The principal is the same. The rate is the same. The only thing that has changed is the term is now 4 years. So my exponent went from 72 to 60 to now 48 payments. So negative 48. That means my numerator is going to be the same again because I didn't change anything in my numerator. My denominator is going to be different. When you calculate this out with your denominator, you should get a payment of $478.92. To figure out how much you paid over the course of the loan, I say, all right, how many payments did I make? I just made 48 payments. 12 times 4 is 48. That's 12 payments a year for 4 years. My payment amount, the amount I wrote the check for, or the amount that they pulled out of my account every month, was $478.92. The total principal and interest payments come out to be $22,988.16. Well, how much of that was interest? I borrowed $20,000. I paid back almost $23,000. So the amount of that was interest was the $2,988.16. Okay, we've been working with the exact same loan for these 3 problems, so it wants us to put it all together. The first time I calculated it, we did 6 years, and that gave us a monthly payment of $340.98 and a total amount of interest as $4,550.56 if you look back on that first page. Number 2 up here, when we calculated over 5 years, we have a payment of $396.02 for a total amount of interest paid, $3,761.20. And then finally, for 4-year term, we had a more expensive payment of $478.92, but we paid less than $3,000 interest. Do you see a pattern forming here? In general, if the principal, number of times compounded a year, and interest rate are the same, then what loan has a lower payment? Well, the lower payment is the longer term loan. Longer term loan has a lower payment. That makes sense because I'm making a lot more payments, so the amount of money gets divided up into smaller pieces. If all those things stay the same, which one has you pay less interest? Well, if I pay it off faster, so the shorter term loan has less interest paid. Now, one thing that this book does not consider and talk to you about is the option of making bigger payments than you have to. My recommendation to you is to get the best interest rate you can. Make sure that you have agreed to a payment amount that you can absolutely make, and then pay as much extra as possible so that you save yourself money in the long run. All right, let's look at the next page. We've got another example. We've got two different loans, same amount of money, same percent of interest. One of them is going to be a 15-year loan. One of them is going to be a 30-year loan. So probably like a house payment or maybe like an RV, something big that you're buying. Which of these two loans would have the lower monthly payment, A or B? Well, B is going to have a lower monthly payment because I get to pay it out over 30 years. But over the life of which loan will I pay back less interest? Well, when I pay it off faster, I pay less interest. All right, let's look at number 5. We've got loan A and loan B. We have two choices to get a car. I'm going to borrow $15,000 for my car. So that's the principal for either loan. Principal is $15,000. Installment loan A, they give me two options. A is a 3-year loan with a 6.4% interest rate. B is a 5-year loan at a lower interest rate. So let's work out these two options and see which would be the better deal. Let's start with loan A. Loan A, for our payment formula, our amount we're borrowing, the principal is $15,000. The rate for loan A is 6.4%, so 0.064 over 12 is my ratio, all over 1 minus quantity, 1 plus that ratio, to the negative 12 times 3-year loan exponent. So my exponent is negative 36. I'm making 36 payments over the life of the loan, assuming I pay it off as scheduled. So let's calculate this loan payment. We're going to pull my calculator back up and we're going to walk through this one again together. Numerator first, we're going to start with our ratio. 0.064 divided by 12, enter, times the principal of $15,000. My numerator, oh that's nice, is just 80. So that will be easy to type back in. I don't have to worry about rounding it off. Now let's look at our denominator. Inside my parentheses with the ratio, 0.064 divided by 12, enter, add the 1, enter, raise it to the exponent. Exponent here is negative 36, enter. Now I still have to subtract. So I have 1 minus this amount. 1 minus that second answer, bring up that amount, and that's my denominator, 0.17, etc. So we need to divide 80 by that. So I'm going to type in my 80 divided by, bring back that answer, enter, and I have a payment of $459.05. So my payment here for this loan choice is $459.05. All right, still two more questions. How much would I pay over the course of this loan? Well, we're paying it off as scheduled. We would be making 36 payments of $459.05. Principal and interest payments 36 times. That comes out to be $16,525.80. So how much interest is that? Well, I borrowed 15, I paid back 16,525, so that is $1,525.80 of interest. That's loan option A. Now let's look at loan option B. For loan option B, I'm still borrowing the same amount of money. So when I set up my payment formula for loan option B, it's still $15,000. My interest rate is different. My interest rate here is 5.1%. So that's 0.051 divided by 12 as that ratio. My denominator is 1 minus the quantity, 1 plus that ratio. And then what's my exponent here? I'm making monthly payments over how long? This one is a 5-year loan. So instead of 36 payments, I'm making 60 payments. So that's going to matter. My numerator also changes here because the rate changed. So I want you to recalculate your numerator. I'm not going to show you with my calculator this time. When you work out your numerator, you should get 6375. And then work out your denominator. Remember, your exponent is a negative 60. Pause the video if you need to. And you see that this is a much lower payment. Much lower payment. But I'm making more payments. Instead of 36 payments, I'm making a total of 60 payments because I'm paying it over 5 years. So the total cost of the loan over the course of 5 years, if you pay it off as scheduled, would be $17,025.60, which means the amount of interest I paid was $2,025.60. Now, which loan is a better deal and by how much if you pay it off as scheduled? And that's kind of the key phrase here. Well, the first loan, I'm paying $1,500 of interest. The second loan, I'm paying $2,000 of interest. So the first loan is a better deal because I'm paying less interest. How much less interest? Well, I need to find the difference between the amounts of interest I paid. So I'll subtract $2,025.60 minus $1,525.80, and I find that I would save $499.80 if I'm going to pay it off as scheduled. But here is the third option that they don't give you to work out. If you would take loan B, it has a better interest rate. And then make payments like loan A. If you can afford these payments, make them at the lower interest rate. And you're going to pay it off faster. It won't take you 5 years to pay it off. And because you're paying more principal every month than you had to, you're going to be paying less interest in the long run because your interest rate is lower, but you're paying it off faster than scheduled. You're going to pay less. That is actually the best deal. Okay, here's another example. We are going to buy a car again. We have two options, either a new car or a used car. Now, hopefully someone in your life has told you that when you drive a new car off the lot, you immediately depreciate and you lose value. So the new car option is going to end up costing you more generally. Notice that the setup for each loan is different. The new car option, the new car is $28,000. You're going to finance it for 4 years at 7%. The used car that is 3 years older, but the same car, is only a $16,000 car. And you can get a 5-year loan for 6%. So less money, lower interest rate. Even though it's a longer loan, remember what I said, in reality, you can pay it off faster. You don't have to pay it over that length of time. All right, let's calculate the payments. That's our first question. Which one has a lower payment? Well, obviously, we can expect that the one that is less money with a lower interest rate is going to be the lower payment, but we're asked how much. So we need to know what the two payment amounts are. If we do the new car option over here, then our payment calculation is $28,000. My ratio is 0.07 over 12. my denominator, 1 minus the quantity, 1 plus that ratio, to the negative 12 times our new car option is a 4-year loan. So 12 times 4 gives me a negative 48 for my exponent. When I set up my used car option payment formula, it's a different cost. It's just $16,000. My rate is 6%, so my ratio is also different. My denominator set up, my exponent is negative 12 times 5 because it's a 5-year loan. So the payments I'm calculating here are what they would be if I pay it off as scheduled. I want you to pause the video and I want you to calculate those payments and find the difference. Okay, the payments you should have worked out would be $670.49 for the new car, $309.32 for the used car each month. Well, that means obviously that the used car payment is lower. And if I find the difference between those two payment amounts, it's lower by $361.17 every month. So the used car is less than half of the new car payment each month. So that's interesting. Then the next question asks, which car has a lower total interest and by how much? Well, to figure that out, we need to figure the total interest for both cars. The new car, you would be making 48 payments of $670.49, which comes to a principal and interest payment total of $32,183.52. So that's principal and interest. We borrowed for the new car $28,000. So if I subtract that amount borrowed, I find that for the new car paid off as scheduled, I would be paying $4,183.52 interest. For the used car, I would be making 60 payments of $309.32. Those are my principal and interest payments. So that's a total principal and interest over the life of the loan as paid as scheduled of $18,559.20. The amount borrowed for that used car was $16,000. So that was the principal, which means the interest part of those payments was $2,559.20 interest. Well, the question, which one has a lower total interest? The used car, again, has a lower total interest. How much lower? Well, find the difference between the total interest for the two loans. The used, you would be paying $1,624.32 less interest if you paid it as scheduled. And again, you don't have to pay it as scheduled. You can save even more than that by paying it off faster and making a larger payment each month. Okay, we have a couple more car loan examples. It says you can buy a car for $37,925, including taxes and license fees. You save $12,000 for the down payment and can get a 5-year loan. Find the monthly payment and total interest. Now, down payment, we haven't talked about a down payment before. If you have saved $12,000 for a down payment, that means you are paying $12,000 when you go get your car. You're not borrowing this much. So how much are you actually borrowing? If the car is $37,925 and you have paid off $12,000, that means the principal you are actually borrowing is just $25,925. Now, when you use your payment formula, this is what you are borrowing, not $37,000. I want you to calculate your payment on this, and then after you pause the video and then come back. All right, for number 7, these are the values that you should have gotten for the monthly payment, and then the total interest over the life of the loan would be $4,597.60. If you did not get those amounts, please go back, recheck your calculation, contact me if you just can't work out where your mistake was. Let's talk about number 8. Number 8 is a little different. Suppose you decide to buy a $30,000 car and you qualify for 0% financing for 5 years. What is your monthly payment? Well, let's think about this. Are you paying interest? Well, no, you're not. All you're doing is just splitting the cost of the car over 5 years of payments. Well, how many payments would you be making? If you're making 12 payments a year for 5 years, you're going to be making 60 payments. And you need to pay that $30,000 out over those 60 payments. So we're just dividing it out. $30,000 divided by 60 is just $500 a month because I'm not paying any interest. So that one is as simple as it looks. All right, number 9, one final question. Suppose you're buying a car for $40,000, including license and taxes. You've saved $15,000 for a down payment. So stop right there and calculate your principal. If it's a $40,000 car and you're paying $15,000 down, how much are you actually financing? Well, you're only financing $25,000 of that $40,000. So when you do your calculations, your principal is $25,000, not $40,000. That's the first tip. You have 2 different incentive options. Incentive A gives you $5,000 off the price, so a $5,000 off right off the top, and then 7.34% for 5 years. Incentive B has no rebate, so doesn't knock that $5,000 off the top, but gives you 0% financing. So let's calculate both of these promotions. Promotion A gives you $5,000 off. Well, if you've already paid $15,000 for the car, and then you take another $5,000 off, you're only financing $20,000. So the principal here would be $20,000. You're going to use that to calculate your payment formula at 7.34% interest over 5 years. When you do that calculation, you should get a payment of $399.24. Go ahead and pause the video, do that calculation, and make sure you get that payment. On incentive B, there's no cash rebate. So you still owe $25,000 for the car, but you get 0% financing for 5 years, same term. That means, remember this last problem? I'm taking that $25,000 and I'm dividing it by how many payments? Well, 5 years is 60 payments. That means this payment would be $416.67. Which is a better deal? Well, incentive A is a better deal by just a little bit, $17.43 a month. Why do you think A is a better deal? Well, even though I'm paying interest, I've knocked $5,000 off the top. Let's see which one has a lower total cost. Incentive A, I'm making 60 payments. If I pay it off as scheduled, because it's a 5-year loan, I would be making 60 payments of $399.24, which gives me a total payback of $23,954.40. Incentive B, there was no interest, so I would be paying back that $25,000 that I owed for the car. Incentive A is still a better deal because the total payment, even though I'm paying interest, I pay less than $5,000 interest, and they gave me $5,000 to start with. So A ends up being a better deal because it was a cheaper car, essentially. And that is what you go back to if you're trying to make a good deal on a vehicle. Start with a cheaper car.